Okay, let's unpack this. The world, well, it feels like it's in a constant state of energy flux, doesn't it?
Absolutely.
Yeah.
Especially with recent geopolitical events.
Yeah, and, we all know tackling climate change requires big, bold moves and, frankly, quickly.
Hmm.
Today, we're diving into a really crucial question for the energy transition, particularly in Europe. Our mission in this deep dive is to explore the findings of a compelling study titled Replacing Gas Boilers with Heat Pumps is the Fastest Way to Cut German Gas Consumption.
Right.
And you'll come away understanding some, well, surprisingly practical steps that can make a huge difference.
And what's fascinating here, I think, is how this study connects that immediate energy security need with long-term climate goals. It uses Germany as a really detailed case study,
Okay.
and it offers a clear pathway forward, not just theory, but concrete modeled scenarios. And it even gets into the ground level insights from installers, the people actually doing the work.
Exactly. So with that big picture, let's zero in on why this study puts such an urgent focus on cutting gas consumption right now.
Well, the trigger was pretty clear.
Yeah, the study highlights how the Russo-Ukrainian war just completely disrupted the supply security of fossil gas. It pushed decisions about, production and transport to an urgent level.
Right, emergency footing almost.
And here's the kicker, or maybe the scary part. These quick decisions, they're threatening to lock in long-term contracts. Contracts that could seriously undermine the Paris Climate Agreement.
Yeah. It's that clash between short-term fixes and long-term goals.
A real double whammy, immediate crisis, future risk.
And if we connect this to the bigger picture, the goals is avoiding that global mean temperature increase beyond 1.5 degrees C. That demands rapid decarbonization of global energy systems, essentially phasing out fossil fuels, all of them.
Right, across the board.
The electricity sector, it's making progress, with PV and wind. But heating is also a massive emitter.
Yeah.
So this study focuses on how heat pumps, powered by renewable electricity, could be a major piece of this puzzle, especially somewhere like Germany, where, 50% of heating relies on natural gas?
50% and another 25% on oil, so it's a big target.
Exactly.
So, okay, the study hypothesizes that installing heat pumps is one of the fastest ways to reduce gas consumption. They point out heat pumps need little planning, little approval, they're modular, kind of like solar panels. That's a bold claim, though. Fastest way. My gut feeling is swapping out millions of boilers isn't exactly, plug and play.
No, absolutely not.
What are the big hurdles the study saw, beyond just the technology itself?
You're right to anticipate complexities, and the study acknowledges them. Heat pumps. They compete for the same renewable electricity that we also need to displace gas power plants.
Right. That's a key tension.
Yeah. And then there are questions about electricity supply on those really cold winter days, especially if building insulation isn't great.
Which is often the case in older building stock.
Precisely. And that's why the authors use such detailed bottom-up modeling, specifically for Germany, because heating is such a huge chunk of their fossil fuel use. It's about finding that sweet spot, where the benefits outweigh the challenges, even when things aren't perfect.
Okay, so we've set the stage, the urgency, the potential solution, heat pumps. Now, let's peel back the curtain a bit and see exactly how these researchers crunched the numbers. How did they model this?
They really dug deep. They looked at Germany's gas consumption with hourly resolution across households, industry, electricity generation, the works.
Hourly? Wow.
Yeah. For instance, back in 2020, German households used, get this, 285 terawatt hours of gas just for heating and cooking.
Whoa, that's a huge number.
It is. And industry, too, especially for process heat below 100 Celsius. Think chemical industry, food processing, paper. They used significant amounts. Like the chemical sector alone was almost 117 TWh.
Okay, these figures are substantial. It really paints a picture of the scale.
Exactly. So here's a fundamental question the study tackled. When we generate new renewable electricity, is it better, more efficient, to use it to power heat pumps, or to directly cut the operating hours of gas-fired power plants?
Ah, the efficiency dilemma. Where do you get the most bang for your renewable buck?
Precisely. And the answer, as this study shows, it hinges on comparing the coefficient of performance, the comp of heat pumps, against the efficiency of those gas power stations.
Okay.
For a typical combined cycle gas turbine, a CCGT plant, this study found an average annual efficiency around 55%, though they conservatively knocked that down to 50% for the modeling to account for grid losses.
Right, makes sense. So 50% efficiency for gas power. What about the heat pumps? What COP did they use?
Well, it varied. For industrial process heat, they assumed a COP of 2, a balance, really.
Okay.
But for residential heating, they went really granular, modeled the COP hour by hour, accounting for different building insulation levels, heating system designs.
And here's something I found really interesting, a potential game changer from this study.
Go on.
It challenges that old belief that you need massive renovations for heat pumps. It found heat pumps can be remarkably effective even with existing radiators.
That's huge, isn't it?
Yeah. They found supply temperatures rarely need to go above 55 Celsius, almost never hitting 70. So forget ripping up floors for underfloor heating in every case. Sometimes, the study suggests, just upsizing 1 or 2 small radiators might be enough.
That is a critical finding for real-world adoption. It lowers that barrier significantly. And the study's modeling was quite conservative on this. They used common air-to-water heat pumps, the kind you can install relatively quickly. They even factored in things like frost formation and defrosting cycles.
Wow, okay.
And for hot water, they assumed an average COP of 2.5. Plus, they made a practical assumption. The worst insulated buildings, energy class H, they'd need insulation upgrades before getting a heat pump.
Sensible.
So this level of detail, outdoor temps, building classes, real-world constraints, that's what makes their scenarios for gas substitution feel pretty robust.
Okay, but theoretical models are one thing. Actual implementation, that's another beast entirely.
Always is.
And this study, commendably, went there. They explored the bottlenecks on the ground. They actually interviewed plumbing and heating business owners in Germany. And what they found was, well, maybe not surprising, but stark. Only 10 to 20% of the, 50,000 companies in that sector regularly install heat pumps.
Yes, a small fraction.
And the reason cited, labor shortages, big time, difficulty finding apprentices, and complaints about training either not enough or poor quality.
It sounds almost like a cultural barrier within the trade, alongside the technical skills gap.
It does, doesn't it?
And the narratives from these business owners, they revealed some really contrasting views. One owner, for example, basically said heating work only happens if the sanitary work is slow, and claimed heat pumps weren't, quote, technically mature and caused problems.
Oof, that's not great.
No. And another owner, someone who did install heat pumps, still hammered home the skilled worker shortage and insisted you need pumps that can hit 70 Celsius or more for older buildings.
Yeah.
Called the ambitious installation targets illusory. A dream dancer idea, I think was the phrase.
Dancer. Wow. Strong words. That paints a pretty challenging picture from the front lines.
Very challenging.
The study didn't stop there. They brought in an economically independent expert to kind of balance these views and their insights. Some real aha moments, I thought.
Yeah. Like what?
Well, the expert agreed on the staff shortage, absolutely. But they also pointed to a recent, quote, big push for training, including practical, hands-on exercises.
Okay, so maybe things are starting to shift.
Maybe. And crucially, this expert stated pretty firmly, heat pumps are mature technology, those initial problems, often just incorrect settings. They dismiss the complaints as, quote, outdated opinions from the 1980s.
Calling them out.
Pretty much. And the expert also confirmed, based on systematic studies over 15 years, that heat pumps rarely need those super high temperatures, even in very old buildings, directly challenging that 70 degrees for old buildings claim.
Right, that's a direct counter based on data, not just anecdote.
Exactly.
And this balanced view, incorporating both the installer's concerns and the expert's perspective, was crucial. It helped them build their most ambitious scenario, the very fast scenario.
Which aims for, 4 million heat pumps installed per year?
A maximum of 4 million per year in Germany, yeah. Ambitious. And this scenario assumes that despite the labor challenges, you can train existing employees. They calculated about 70,000 people could be trained over a few years with just a 3 or 4 day practical course.
Okay, that sounds potentially doable with focus.
And it assumes installations can be done efficiently, allowing for those minor radiator tweaks when needed. So, ambitious, yes. But they argue it's not utopian. It requires real concerted effort. Government, companies, customers making installation lucrative and, smoothing the path.
Right. Cooperation is key. Okay, let's talk about the big payoff then, the results. This study modeled 4 scenarios. The baseline one, the installer's roadmap, which was based on pre-war growth. Well, it barely moved the needle by 2030.
Yeah, pretty slow progress there.
Under the very fast scenario, the results are significant. By 2025, just a few years out, It achieves about 30% fossil gas savings overall.
30%. That's roughly 290 terawatt hours, or 28 billion cubic meters of gas.
Wow. Put that 290 TWA into context for us. How much does that really move the needle for Germany's gas dependency, especially dependency on specific sources?
Okay, so let's try. Roughly half of Germany's gas in 2020 came from the Russian Federation. This study suggests that the very fast scenario could substitute approximately 60% of that specific gas volume by 2025.
60% of the gas previously coming from Russia in just a few years.
According to their model, yes. It clearly shows how these targeted efforts could slash price volatility, reduce supply risk, and move Germany decisively towards meeting its Paris Agreement commitments.
It really is that dual win, isn't it? Energy security and climate action.
Absolutely. And the environmental benefits they calculated are substantial, too.
Mm-hmm.
At least 180 million tons of greenhouse gas emissions saved cumulatively by 2025.
That's a serious chunk of emissions. Okay, what about the grid? All these heat pumps need electricity.
A crucial point.
The study looked at how newly added renewables get used, right?
Yes. In the initial years, new wind and PV capacity mostly just reduces the runtime of gas-fired power plants. Makes sense.
Standard substitution.
But in that very fast scenario, especially in 2024 and 2025, things shift. Heat pumps end up drawing a whopping 70% of the newly added renewable power.
70%. Okay, that highlights the massive need for new renewable generation and the grid to handle it.
Exactly. That's a huge underlying assumption. Sufficient grid expansion must happen in parallel, a major undertaking on its own.
I'm kidding. So what happens further out?
Well, the study projects that later on, maybe around 2030 or so, as renewable capacity keeps growing, gas power plants get relegated mostly to backup duty, dealing with lulls like windless nights.
Okay.
Around the point where renewables hit maybe 80% of electricity generation, which they expect around 2030, more and more clean electricity becomes available for other things, phasing out coal, powering EVs.
Right, it enables the next steps in the transition.
It really shows that holistic strategy, each piece fitting together in a larger puzzle over time.
Okay, but like any complex model, there are approximations, limitations.
Always.
And the study is upfront about them, which is good. It acknowledges that big assumption about sufficient grid expansion. That's a huge if.
A very big if in practice.
And also, while heat pumps can be flexible using buildings for thermal storage, running when power prices are low, the study's load curves didn't fully capture all that potential flexibility.
Right. They kept the modeling perhaps a bit more straightforward on the demand side there, which raises an important question for you, the listener, to think about. What are the boundaries of a model like this? It focuses on newly added capacity. It doesn't dive into the nitty-gritty of transmission grid congestion, which could definitely be an issue in that very fast scenario.
Especially with 70% of new renewables going to heat pumps in specific years.
Exactly. And it's not really designed for scenarios beyond about 80% renewables on the grid.
Yeah.
Because that would need adding other kinds of balancing capacity, maybe multi-fuel engines, more storage, things beyond the model scope.
So, important context to keep in mind when thinking about the real-world rollout.
Definitely. Critical thinking points.
But even with those acknowledged points, this study offers clear, tangible pathways, especially that very fast scenario. It shows a route to significant gas reduction and faster climate action. And while the numbers are specific to Germany, the methodology, the core message, it feels broadly applicable, doesn't it?
I think so. For other temperate countries facing similar challenges, absolutely. The lessons learned here, the approach, they resonate beyond German borders. Crucial insights for anyone grappling with energy security and climate goals.
Yeah.
What's really fascinating, I think, is the clear evidence here. It shows that with targeted, cooperative efforts, government incentives making it worthwhile, a real training offensive for installers, plus that necessary grid expansion, then accelerating heat pump installations is an incredibly effective strategy. A powerful way to slash fossil gas use, even using existing radiators in many cases.
So, wrapping up, what does this all mean for you, the listener? This deep dive into replacing gas boilers with heat pumps is the fastest way to cut German gas consumption.
Well, it reveals the path forward often involves practical, scalable solutions.
Things we can actually do now.
Exactly. Supported by detailed analysis, yes, but also needing that willingness to tackle the real-world bottlenecks, the human factors.
It underscores that we often have the technology. The biggest challenge might just be in the execution, getting it done on the ground.
Agreed.
So consider this. If a very fast scenario, according to this detailed modeling, can potentially cut 60% of a major nation's critical gas imports in just a few years. What similar, maybe overlooked, fastest ways might exist in other parts of our global energy transition? And what really stands out to you about that balance, or sometimes the tension between the technological potential and the human factors needed for implementation?
Good question to ponder.
Thank you for joining us on this deep dive into the numbers, the narratives, and the urgent necessity of our energy future.